everyone. Just wanted to spend a little bit more time talking about how to put your answers in in interval notation. Just since I think it comes up a little bit more than I think I had realized within the context of this book, and it's still a good skill to have for going forward in your mathematical careers. So let's just work our way through a couple of these problems and then look at what interval solution or notation, I'm sorry, what interval notation looks like. So as always, we're going to solve this the same way we would solve pretty much anything that you get where you have an equation or an inequality. So add the 5 to both sides. Negative 7x plus x is greater than or equal to 30. Sorry, a little bit of delay there. Okay, so then when we combine, you'll get negative 6x is greater than or equal to 30. And then when I divide by the negative 6, as we recall, when we multiply or divide by a negative on both sides of the inequality, we have to remember to flip the inequality. So it is going to be x is less than or equal to negative 5. Now, we're told to graph the solution set, and to provide it in interval notation. So when we're actually graphing this, I'm going to be super lazy with my line. So I'm just going to put 0 and then negative 5 here. I'll put 5 over here for good measure. Now, this is a less than or equal to, so we do need a shaded in circle, okay? And less than left. So anything less than negative 5 works. All right. Now, that's how we would graph the solution, but we're also informed to put it in interval notation. So what does that look like? When we're looking to figure out interval notation, essentially what we are doing is we're writing down the range of values that we could have. We're just expressing our set based on the start points and the end points of the set. The only tricky thing is that we're just saying it has to be less than negative 5. There's no definitive lowest value that'll work. So if we keep going forever and ever and ever in the more negative direction, we have to denote that somehow. And the method we use to denote that is we use negative infinity. All right, so all I'm going to do with this is I'm just going to say x, and I'm going to use this symbol that looks kind of like an e. It's just saying it's an element of. And the reason behind that is because when we're putting it into this notation, we need to make sure that we're just saying that x is within this kind of range, this interval of values. And we're starting off at negative infinity. I don't know exactly what it is. Obviously, it keeps going on forever and ever, so I do know what it is. It's just anything less than negative 5. But there's no beginning of this interval. It's an infinitely large interval that just goes on forever in the negative direction. However, it does stop at a certain point in terms of a maximum, right? So the largest value that'll make this inequality true is negative 5. And I have to include negative 5 in this range. And the reason we're including it is because of the equal to component right there. So when we have the including it with the equal to, we use a bracket. If we didn't have that, we would use a parenthesis, right? So if you have the closed circle, bracket, if you have an open circle, parenthesis. Okay. And that would be how you express it in interval notation. You don't always need the x as an element of. I believe the way that they write it within the homework problems, they just use the negative infinity to negative 5 component. All right, now let's look at this one. Remember, when we're dealing with problems where x is on both sides, or there's a variable on both sides, you could end up in a scenario where you get like x is less than or equal to negative 5. You could end up in a scenario where it's always true. You can end up with a scenario where it's never true. So when it's always true, you're essentially going to use this sort of, when you have a specific value that it has to be greater than or less than, you're going to use this type of reasoning to do your interval notation. If you end up in a scenario where there is no solution, so if you ended up with something like negative 5 is less than -6. Yeah, but that's just not true. So that the way we express that interval is this. This is the empty set. Okay. So if you ever see the circle with the line through it, that just means it's the empty set, which means there's nothing in that interval. It's empty. It's closed. Closed isn't the right word. It's just empty. There's nothing in it. And then finally, on the other side, if you got -6 is less than -5 as a solution, that's always true. And the way you would represent that is just any value. So -infinity, comma, infinity. Okay. All right, so let's actually do this out. We have, when I distribute 10x plus 20 is greater than 8x minus 32. Okay, subtract the 20. I get 10x is greater than 8x minus 52. Subtract the 8x. I get 2x is greater than -52. And then I get x is greater than -26. Okay. So if I were to graph that, 0, -26, 26, and you feel free to use more numbers. I'm just being very general with my graphs. All right. So it is greater than, it is just greater than, so I need an open circle. Greater goes to the right, because we're getting bigger. Anything bigger than -26 goes off to the right. Now, how do I actually express that in interval notation? So again, we're going to start off by saying that my x value is an element of this interval. Now, as I said, on the other side, we were saying we could go off forever and ever and ever, and then more negative answer. There's always a more negative value I could put in. That's why I did -infinity. However, in this case, the lowest value that I could put in for this, we're already told. We know that 5 is the cutoff. Not 5, 26. Sorry, I got the wrong problem. 26 is the cutoff, or -26 is the cutoff point. So we know we're going from -26. However, we are not including -26. And the reason we're not including that is because we're not saying, if we included it, it would be saying that -26 is greater than -26. No number is greater than itself. It is equal to itself. So we cannot include 26. We wouldn't just go to the next number up and say, well, let's just go -25. Because technically anything between -25 and -26 would also make this work, which is why we need to get as close to 26 as possible without actually hitting 26, which is why we use a parenthesis here. And now we go on forever and just get bigger and bigger and bigger. There's no stopping point on the other side. So we're just going on forever and ever and ever. And that just means on the other side, we're going to have the infinity. Okay. So this is how you would actually use the interval notation to illustrate the solution set to an inequality problem. All right. So please let me know if you have any additional questions. I hope this helps. Have a great day.